So you all remember that containers or pods by default are ephemeral in nature. That is, whenever it gets restarted, data on it will be lost, right? So in Docker we saw that there were Docker volumes. Okay, similarly in Kubernetes we have Kubernetes volume. Okay, so why we need volumes? To keep that data longer than the pod's life cycle. A plot's life cycle means after restart also it should be able to retain the data. Okay, the data will be retained on the external volumes. Okay, uh, it can be also used to share the data among various pods. Okay, the same volume can be shared among different pods, but that volume should be shareable. There are some volumes which are shareable, some are not. Okay, and we can use external storage systems such as cloud storage or object storage as well. Okay, to create such volumes. And last time we saw that there are some OCI and CRI standards for containers. Similarly, there are some CSI, the standards for storages all as well. So suppose somebody launches their own storage system, then they should follow the guidelines followed by CSI standard. Okay, or or you can say the protocol. And the CSI will follow all the means whatever storage, including cloud-based storage, object storage, or any traditional block storage. The new provider should always follow the CSI standard. So before we learn about volumes, we should understand some few concepts like persistent volume, okay, and persistent volume claim. And the third definition is storage class. Okay, so let's start with the storage class. What does the storage class means? It is used for dynamically provisioning the persistent volumes. So there are two types of volumes. That is, there are two types of persistent volumes. That is static and dynamic. Static means we can create beforehand before using it in the any of the pod or deployments, and dynamic means it will be created on the fly. So most of the dynamics are created in the cloud. Okay, and static ones we can create locally first, and then we can attach it. So the storage class means, suppose we are using an NFS share, then the storage class will be NFS. So if we are using a local, then it will be local. If we are using AWS, then it can be AWS EBS. Okay, if we are using a Google Cloud, then it can be Google Storage. So such different storage classes are also possible. NFS, cloud based, or even you must have heard about CEPH. Okay, so all those storage classes are provided, are possible. So first we define the storage classes. If it is cloud, it is by default defined. Okay, then we'll define the persistent volumes, and from those persistent volume we'll create persistent volume claim. That is, the pod will claim that persistent volume, that I need this much amount of storage. Okay, so how it works? Suppose the admin will create a persistent volume. Okay, the pod will claim it, and the PVC will be attached to that particular pod. This is how it works. Okay, so and how we define how we define it, the definition of PVC is similar to our deployment services and all. We'll define a API version, kind, and metadata. That I need a Nginx PVC. The name of the PVC itself is Nginx EVC. It should be read write once. Read write once means it cannot be shared, and if it is read write many, it can be shared. Okay, so then we'll define the storage class. In this case, we are using micro K8s. Okay, so micro K8s storage class will be micro K8s host pass. That means create a storage on this micro K8s node itself and use it. So it is claiming 1 gigabytes of persistent volume. Okay, so it creates persistent volume claim, and then to use it in any deployment, we'll have to define a volume. Okay, that I need this persistent volume. okay, whose name is html volume, okay, and use this volume which is created here. Okay, so this volume will be defined here, that we are using it, and that even if, though it is a volume, it needs to be mounted somewhere. So in this case we are mounting on it on USR share nginx html. Okay, so that was some theory about PVC. I'll quickly give a small demo and then we'll understand it properly. So I'm just logging into my VM. So let's see if it's ready. kubectl get all. You all also can follow along with me. So the exercise which we are doing is this one, exercise number 1. Create nginx container and access web page via PVC. So we know that the default web page location is USR share nginx. Okay, in that folder will mount it on PVC, so the data will be on that PVC. It will even though the pod or the container gets restarted. So there are few steps. Just you all can follow along with me. Exercise number 11. So I'll do some cleanup. Kubectl delete deployment app1 app2 services. Okay, I'm just deleting it. Need to remove get. Okay, kubectl get ingress. We created ingress as well. So kubectl delete ingress. So that everything is clean. Then let's check micro K8s status. So micro K8s has made it very easy to use PVCs as well, just for the learning purpose. So if you see, last time we enabled ingress and metal LB. Today we'll enable this host path storage. Storage class allocate storage for host directory. So even though we are calling it as a storage, it creates a directory. Okay, that directory is shared among the pods. So let's check kubectl get storage class. Okay, so no storage resources found, nothing is defined. Let's see if PV is defined. No, then PVC. So from persistent volume, we claim the persistent volume claim. That's why it's called PV and PVC are different. So nothing is defined here. So what we will do is we have checked with the micro creator status that it is not enable micro creator status host path. Micro creators host path is not enable. We'll enable it. Okay. So this one will enable. So the command is micro creators enable host host path storage. And in cloud we don't need to enable all those things. It uses by default. Similarly, similar for means as we did for load balancer as well. In cloud, the load balancer, when we define, it is automatically allocated some public IP address. Similarly, for PVCs also in cloud, we just need to define it. We don't need to enable and all. So just check the microcata status. So storage is also enabled. Now if we see kubectl get storage class, it will show that it's using microcreators, means for all the deployments. This will be the storage class. When it is defined in the definition, it will be claimed. Okay, so waiting, if you see here, reclaim policy is delete. Okay, that means the PVC will be deleted. We cannot get it back when the pod is deleted. Wait for the first consumer means it will be created, but until and unless the pod gets restarted, it will not be binded to that particular pod. Okay, so that's why it's saying wait for consumer, and it cannot be expanded once defined. We cannot expand it. This is the default nature. And just see PV, still the PV is not created, and even the PVC is not claimed. Okay, so we have only storage class. Now let's define our first PVC. So let's first create a directory called mkdir PVC example. In that PVC will store. So Nginx PVC we are creating. The size, so what we are defining, create an Nginx PVC. Storage class is micro K8s host path. This is the one. And we are requesting 1 gigabytes of it. So before this, kubectl get storage class PV and PVC. Okay, so only storage class is defined. Let's create PVC. So it is created. Let's check it again. So we have storage class as micro K8s, and PVC is pending because the pod is not yet created. Okay, so it is still in a pending state, PVC. Now let's create a pod. We are creating a deployment, and the deployment will create the pods. In this we are also using service. So we are creating a deployment, Nginx deployment. Only one pod will be created, one replicas. It is using the Nginx image. Okay, container port will be 8. Then we are creating a volume. Okay, means we are mounting a volume. The volume is defined here. Its name will be HTML volume. It will claim it from the Nginx PVC. Okay, and it will mount it on USR share Nginx HTML, so that whatever code which we store it in the USR share Nginx, it will remain persistent even after restart of the pod. And we are defining a service of as cluster IP. So just define kubectl apply -f nginx deploy. Now the kubectl get all. Okay, so it started creating the pod. So sometimes there can be error. So how to check the errors? Kubectl get events. Okay. So there are no errors. So it is saying successfully assigned. Deployment volume is also provisioned. So let's check it again. Kubectl get all. So as the pod is running now, if you see PVC, okay, it is binded. So bound means a PVC is created of 1 gigabytes. Okay, and it is attached to the pod. So to check that, we'll have to go inside the pod. Okay, now what has happened is the default Nginx page will be in. So let's first go inside the container kubectl exec -it interactive terminal for this pod -f/bin bash. We are going inside the pod, and if you go USR share nginx html. Okay, it is empty. Why it is empty? By default it was not never empty for us, but if you see, so if you see, a volume is created, okay, and it is mounted on USR share nginx, okay, HTML, the one which we created. That's why whatever index page it was already there, that it will not show. Okay, so whatever contents of the volume which are mounted on USR share nginx, that will be showed. Okay, and in this case we just created the volume. We did not put any data into it. So if we do kubectl get all, and if you curl the cluster IP, it will not show anything. Okay, it is giving a forbidden page. Okay, that it was not able to find the index.html page. Now there are two methods. Okay, so we'll see the second method first, to create some data in USR share nginx. So while copying it, copy it properly. So what we are doing is, so in kube system we are checking the host path. Whenever we enable the host path, okay, a deployment with that host path was created, and a pod for that host path was created. In that, okay, just get this name, the pod name, and again copy it. So what we are doing is, we are describing this host path provisioner pod, okay, in kube system namespace. Okay, so I just copy pasted from the exercise. The name will be different. So this is the name of the pod. So when we grep it, so on this micro system, which is just for learning purpose, in this default location, it has created that volume. Okay, so where snap microcators common default storage, here that volume is created, will go inside it, this default. Okay, so this is empty. That's why the no page is showed. Okay, so what we will do is, we'll create an index.html page. So we'll have to see it here. So this is the index.html page we are creating. So whatever contents we want to give, we can give. In this case, this app, this is my app on PVC, and just do Control D. Okay, now let's do kubectl get all. Check the cluster IP curl. So the now data is served from the particular PVC. Now again, let's go inside the exec, inside the container pod. In short, we can say cd usr share nginx html. Okay, this index.html. It has the same data. Now let's append something into it. This line is added inside the container. Control D, cat index.html, Control D, just to curl. Okay, so the data is automatically saved in that volume. Now again, if you go to that particular directory where the volume was created, it was here, cd cat index.html. So we have the data, persistent data here. Okay, So this is a bit tricky to find the path where the micro saves it. Okay, but in production environment, you don't need to find it. You just save it, and it will be automatically saved in the volume which was created. Okay, so this is the exercise for PVC. So if you have any questions, let me know.